Hi, I'm Doc Palmer. I'm the author of McGraw-Hill's best-selling reliability book, the Maintenance Planning and Scheduling Handbook. It's been their best-selling handbook for the last 20 years in the reliability area. And I've been really enjoyed and blessed by being a part of that. Planning and scheduling gives us a pop in productivity. It enables us to answer the management question and solve it, which is, how can we do more proactive maintenance when our hands are honestly full of reactive maintenance? We get a pop of 50% to do more proactive maintenance. But it doesn't just happen because you hire planners and schedulers. Chapter 2 of the book explains that you have to run planning as a Deming cycle to do better job plans over the years. Chapter 3 explains you have to fully load schedules to defeat Parkinson's law and expect lower scheduling compliance, but you have higher productivity, which was our real objective from that. We started talking last time about reactive maintenance. Planning and scheduling reduces reactive maintenance because you're doing more proactive maintenance. It also reduces reactive maintenance because you're working on things more intelligently over the year by running planning as a Deming cycle. If you work on a pump more intelligently so it doesn't fail as often, you have less reactive maintenance. It also, the reactive maintenance that you do have, that's not emergency. Emergency work will be glad to help out with data. The urgent work, though, that doesn't have to start today, check with the supervisor. If they're not going to work on it today, knock out a quick job plan. So we can help some reactive job. And some of that reactive job that we knocked out a job plan for, they don't do this week after all. So put it in the schedule for next week. Today, also in Chapter 4 with reactive maintenance, what I want to talk about today is the discussion of blanket work orders. They're just awfully abused. The idea of a blanket or standing work order is that, instead of making somebody write a work order, submit it, and get it through the system, have it planned, scheduled, and blah, 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 just tell the maintenance people. And anything that supposedly takes less than 2 hours, doesn't need any spare parts, don't bother with a work order. Just tell the maintenance people, and they'll take care of it. That sounds good, but the problem is several problems. One is that they get abused. Where it's supposed to be a small job where you don't use any spare parts, there'll be somebody out there replacing a major control valve. They've got 2 or 3 people, they've been working for the entire day, and they're going to charge it to a blanket standing work order. You've lost the history on that control valve. So it destroys our history. What's your most troublesome equipment? Well, we don't know because we don't charge everything to work orders. Your reliability engineers need that information. Not only that, we're not running the Deming cycle. What were the parts you used when you replaced the control valve? What tools did you need? How long did it take? You don't know because you're not using a work order where you can record the feedback and do a better job the next time. So you're ruining asset history, you're damaging your reliability program for your engineers, you're destroying our Deming cycle, you're not getting better when you're working on stuff. And then on the scheduling side, you're making scheduling mushy. That's a technical word. We're fully loading the schedule, but we leave 10% of that for blanket work. No, you're not. You're underloading the schedule. You're only loading the schedule 90%. But we know we'll have some blanket work. Well, how much blanket work? Well, I don't know, typically about 10%. You're making the whole thing mushy. And if you don't fully load the schedules to defeat Parkinson's law is the amount of work assigned expands to fill the amount of time available, you're not getting a pop in work order completion rate because you didn't fully load the schedule. Well, we're fully loading the schedule. We're just leaving time for blanket work, or we're leaving time for reactive work. No, you're not. You're just underloading the schedule. If you underload the schedule, every job on the schedule that you do next week will take a little bit longer than it should. Every reactive job that you come across takes a little bit longer than it should. Every standing little job that you're going to charge you a standing or blanket work order probably takes a little bit longer than it should have. And Parkinson's law, it's a real thing. It's not people just standing around. Everybody's busy. Everybody's doing something. Everybody's got a job to do. We're taking care of operations. We charge little things to blankets. We leave room on the schedule open for reactive work because we know we'll have some reactive work. Yeah, but you're only at 35% wrench time. You're not fully loading the schedules to give your supervisors a mission. Your supervisor mission is take care of operations, make sure everybody has something to do. That gives you 35% wrench time. The first chapter of the handbook expects that the planning and scheduling should pop that up to 55% wrench time. And you don't have to measure it. That's just explaining what's going on. Going from 35 to 55% wrench time is a 57% improvement. It translates to what I call a 50% pop and work order completion rate. If you plan the work so you can fully load schedules. You're not fully loading the schedules if you leave a big chunk there for this blanket work. You're not fully loading the schedules if you leave a chunk there for reactive work. So on the blanket work, try to avoid those like the plague. Doc, you would make somebody write a work order for hanging a bulletin board? Sure, make them write a work order if they want it done. Don't kill yourself making a job plan. You know, it's, okay, one helper, one bulletin board, 1 hour. Have we got the bulletin board? Yes. That's the plan. I wouldn't make a reusable plan in your computer system. I wouldn't make a equipment file in the library, but I would plan it. Yeah, make somebody write a work order, knock out a job plan. Doc, you would make somebody write a work order for moving a couple barrels of chemical from one side of the plant to the other? Well, sure I would. I need these barrels moved from this side of the plant to the other. Okay, that's one mechanic, one forklift, 1 hour, one environmental form. And the planner should go look at the job. You know, it's not 2 barrels. It's 5 barrels, and one of them doesn't have a label saying what it is. You can't legally move those without the environmental engineer verifying with a sample what's in the barrel. Just, yeah, knock out a job plan. But that didn't take me long to do it. I checked, it doesn't have a form, can't move it. Send it to the environmental engineer. Then it's 5 barrels. Okay, well, that's one mechanic, one forklift, 1 hour, and the environmental form's been done. You know, that just, it's part of our process. Don't go around the process. And we do that because we don't want to bog down planning, and we don't want to get in the way of supervisors going out and doing stuff. But you can still do that with work orders and stuff. Don't avoid using work orders. Blankets, smother productivity. That's my tagline here. So, just a short lesson today. Thanks for letting me be part of your maintenance family. I really value that and appreciate that. I value all of you. So thank you, and God bless, and we'll see you next time.